Hi folks, it's John again. Recently we did an article for the magazine on simple breadboard ends, and I had one workpiece here that I hadn't finished attaching yet, and I thought, well, let's get this on video before I throw everything away, just so those of you who like to see it in real time visually can see the process, and I'll kind of explain to some of the little things that I am trying to do as I go through this process. Really what we're doing is we are trying to keep a panel flat by adding a cross grain piece on both ends. The problem you get into is that the panel itself is going to want to move with seasonal changes in humidity. So these panels are flat sawn. The vast majority of their movement is going to be side to side. If you have a quarter sawn panel, a little different grain movement, but we went with flat sawn because this would be something you'd see in this instance like a simple cutting board, or often you see these on tables. Knowing that a panel like this could move 1/8 of an inch from summer to winter, we're going to have to build in something in these pins so that the wood has somewhere to go so you don't crack. With this simple style, what you can do is actually let the wood expand out through the end. And actually I can feel that on there. Just in a few weeks, this was cut flush and this is starting to stick out the end just a little bit. So what I did, I drilled 2 holes here that pin it in place, but then the hole inside here that's going through this tenon is an oval, so it's elongated. The pin holds the breadboard end on, but then it's also allowing this to move side to side. First things first, we have to make sure that the breadboard end will actually go onto the panel. The process that I use to cut this, you might notice there are some little ridges on this. Everything was cut with a dado stack at the table saw. These little ridges that you see are the outside 2 blades that just have a little bit of a ear on them that'll cut that ridge in there. If you really don't like that, you could cut this thick, use a shoulder plane to plane that off, or you could also clean it up at the router table with a straight bit. This was also cut at the table saw, and this usually is kind of your limiting factor, is how deep of a groove you can make in your breadboard end. You might notice on the end there's just a little bit of room right between the end of this tenon and the base of that groove. I don't want to put that on and have the tenon bottom out. When this goes in tight, I want this connection point to be my tight point. This I want a little bit of room. I have my center marked. We're going to call center good right there. And with this, I feel pretty good. It's not wanting to fall out. I need to locate where these holes are on the tenon that goes through the panel. So all I'm going to do is use a brad point bit, put it right down in the hole, and I like to spin it backwards. If you spin it the other way, it could start trying to cut a hole, if you will. The center point on that brad point bit should have left an indentation at each hole location of where these holes are going to be. We have a hole right here, here, and here. Now, I alluded to this earlier. We're going to draw bore this as well. If I was very sloppy with these holes and I started drilling holes this direction of where my hole location actually is, when I drive these pins on, it would actually push the breadboard end away from my joint, and you'd have a crack open up. So if I drill my holes on the opposite side, if I drill these holes leaning a little bit towards this shoulder here, when I drive these pins in, it's actually going to suck this in tighter. You can go too far where the offset is so much you can't get the pins in and you'll start breaking them off. But if you cheat it just a little bit, again, we can pull that joint tighter, and that's called draw boring. This is an old technique that has been used on furniture forever. and also a lot of timber frame buildings. So all I did there was mark my line square. So if when I move this center point, I'm not shifting it left or right, I'm shifting it 90 degrees. So what I do typically is I'm going to move that hole in. It's not much. It's about like a 32nd of an inch. If I was dealing with a lot thicker stock, moving that center point can be a little, you can go up to 1/16 of an inch, for instance. But for what we're doing here, we're going to keep it pretty close. Now that I have that marked out, I want to drill these holes as straight as I can. So I'm going to return to the drill press and we'll do that. So again, with a smaller board like this, I'm going to keep these two tight. So we're going to leave those alone. These are the only ones we're going to be working on. If I was working on a larger board, like let's say we added 3 or 4 inches to this, instead of 4, I might do 5, pin the center one, and then the next 2 are slightly slotted, and the back 2 are more slotted. Another way you could do this, again, if you're looking at a table, desk, something built in, is you could pin the front one and then the slots get progressively bigger as you get to the back. So then the front would be pinned and the panel would be allowed to move freely to the back with, depending on what time of year it was. Really, you have a lot of options with this. You just have to decide kind of how you want to relieve some of that wood movement. What I typically do is take a marking gauge. So this is a wheel marking gauge that has a little micro adjust. It makes it easy to line this up. And I set this right on the edge of these holes. And this is also a nice way to check that my holes are actually ending up somewhat in the same location. You could use this as well to scribe out where your center points are as well. I've scribed a line on this and this hole. And of course, the line is almost right where the dado stack left a score mark. But it's enough that I can still get a pencil in, run right down that marked line, and then this gives me my baseline for making that slot. Now, depending on what works well for you, sometimes I'll stand this up and file the slot out. For what we're doing today, I think I'll just put it horizontal, clamp it to the workbench here, and we'll run the rasp up and down. Okay. So again, what I'm doing here is trying not to go over this line. I can apply pressure and start filing towards the shoulder, and it doesn't matter. But if I start filing too far this way and get over that line, then that will loosen up that draw bore joint, or the ability of the pin to keep the breadboard pulled tight to this panel. So typically you'll see, a lot of times when I'm doing this, it's almost like a kidney bean at first. I'm just getting it started, trying to elongate that slot. And then at the very end, I'm coming through and bringing it up to that line. Again, with a panel of this size, maybe I'm expecting at worst about 1/8 of an inch of seasonal movement. So these slots don't have to be very long at all. With a larger panel, you have to make the slots a lot longer. And if you got really picky about this, you could definitely set up a router and you could route these slots out. This one I'm getting a little bit closer to that line than I like. Now, if you feel lucky, you can put these on and just start driving pins in. Your pin selection can work for you or against you, if that makes any sense. You might want to think a little bit about double checking the size. So for this, we're going to use some walnut pins. I found some dowel stock that was relatively straight grained. And the first thing I do is just use a little pencil sharpener to get a little point on there. But in reference to this, again, try to get as straight grain as possible. If you have grain that's running out when you pound this in, especially with smaller pins, 1/8 inch is the worst. You'll pound it and the pin will just shatter and it'll shear at an angle, and then you have to go into panic mode. The other thing I like to do is double check the actual diameter of this pin. And one thing you can run it through is a dowel plate. This is pretty simple in that you're just driving your stock through that plate, and everything that's oversized is going to shave off. This is a very simple, easy to use plate. And you can see mine has been around for quite a while. So this is the one I have to do my imperial size holes. This is another version as well. Just a different manufacturer makes it. So instead of selling the full plate with all the holes, this is actually the part that you're driving the pin through to shear. So it comes with an insert. The wood block itself grows on trees, and it has a hole drilled in the bottom for the pin to fall through. The reason I brought this one out, this one is actually not imperial. This is 6 millimeters. So if you use like 1/4 inch a lot, you'll see this on 1/4 inch dowels where maybe this isn't the best one. So you'll get these dowels that almost fall through the 1/4 inch, but you can salvage them with the 6 millimeter. So if you do like I do, where you buy a bag of 25 and they're all undersized, it's also a way to kind of salvage that. So what I'm going to do at first, I'm just going to pound these just far enough that it starts pulling this together. And then we're going to get this in a clamp. So this will do two things for me. The first is it's going to hold the ends of this breadboard on. So as I'm pounding, it has nowhere to go. It can't escape. The other thing is it's going to give me clearance so that when I pound these through, remember we sharpen the end. We want to go past where that's sharpened. And we got more than enough length on those. And I don't know how much it's showing up, but you can kind of see the effects of that draw bore as this goes in, because the holes are offset. So this will go straight for a little bit, and then it'll hit that draw bore, and you can actually watch the pins start going back and forth as it's traveling through that offset hole. Okay, so we have this on. To finish this off, what I would do is take a flush cut saw, cut all these pins off. Also might notice on this panel, I left the panel wider on both sides than the ends. This is to make it a lot easier to clean up. Now I can just go over to the table saw. One edge goes right up against the rip fence. Cut that side flush, cut this side flush. Hopefully you got something out of this. So, thanks for watching. We'll see you next time.